Obviously, the panel topic today is IoT. I think everyone knows what that stands for, but just in case, Internet of Things. We'll talk about the privacy and security aspects of such. Privacy being more on the consumer side, security being probably more, arguably more on the industrial side. Though on the consumer side as well, the Jeep brake test, so to speak, certainly got people's attention, consumers' attention this summer as well. My name's Tim Mather. I'm the Chief Information Security Officer at Cadence Design Systems right here in the Valley. I'm your moderator for today. Our panelists, let's start on the end, please. My left, your right, Lorie Wigle. Lorie is the General Manager for IoT Security Solutions at, don't call us McAfee anymore, Intel Security for that. Sitting next to her is Charles Chi. Charles is the Senior Design Engineering Architect in the Intellectual Property Group Business Unit at Cadence Design Systems. And next we have Professor Yuval Elovici. He is a member of the Gurion University of the Negev, which is in Beersheba. He's in the Department of Information Systems Engineering and is director of the university's Cybersecurity Research Center. For those of you, I'm sure many of you do, follow Israeli cybersecurity developments. Obviously, the government has a major push underway to move those efforts south to Beersheba and, if you will, consolidate those operations there. And sitting closest to me here is Asaf Ashkenazi. He is the Director of Product Management at Qualcomm, and specifically for security-related products, I believe you said? Yes, okay. So 4 panelists who very well qualified to speak on the subject here today, certainly from a chip perspective and from a cyber security product perspective. So let's start, and by the way, please, questions encouraged from the audience. Let's make this as interactive as possible. If it's batch mode from us to you, that's rather boring. Interactive is a lot more interesting. So we encourage your questions off of that. So let's start on the consumer side, if we will, and really more the privacy concerns. I'm sure all of you have seen the recent reports in the media, Nest thermostats being hacked, various cars being hacked, whether it's their braking systems or certainly their keyless entry systems. I think we've got 7 or 8 companies now that have fallen prey to that. I read recently in the Times of London that the problem is so bad for Jaguar in the city of London that they're raising the insurance rates there, which is interesting. But we've got all kinds of consumer devices out there that are being hacked already, and doesn't seem to be much hope in terms of securing those devices. Lorie, let's start with you, please. Why is that? What's the problem here, please?
There are multiple problems, but one to begin with is a lot of the companies that are making the new devices for home aren't factoring security into their designs. And I think, this is a common phenomenon that we see in industries when they're in their startup phase. People are trying to make things work, and they tend to, unfortunately, think of security as an afterthought. So I don't think we're seeing a lot of security by design. There are good solutions, and so I think this is a situation that's going to improve over time as we educate people, consumers on what they should be asking for, and the manufacturers on what they should be building in. One of the things that we think is really important is to evolve technology that does preserve privacy. And one of the things that we're working on, again, that can be built into new devices using Intel silicon, can take advantage of something called Enhanced Privacy ID, or EPID. This is something that we have contributed to ISO as a standard, and it has the capability of identifying a device uniquely, but also being able to be used in a pattern where the device can be authenticated, securely authenticated as part of a group. And we use it most commonly to qualify our parts as genuine Intel. But there are lots of applications. If you think about something like a smart driver's license, as one example, that would be a consumer device. When you go into a bar and need to prove that you're old enough to drink, the EPID technology would securely attest that you're of drinking age without revealing your address and driver's license number and all of those other things. So again, this capability of being either unique or as part of a group, we think is an important enabling technology. And, I probably went a little afield of the question, but I wanted to make sure I got my comments in so I took the advantage. Thanks, Tim.
All right. So, Charles, Cadence obviously supports a lot of the chip manufacturers out there. What kind of, I'll say, demand are you seeing where the chip companies are, I'll say, getting serious about building security into their chips?
So I would say in particular, on IoT devices that we're seeing, we get a lot of customers requesting security and some security technologies. And I would second Lorie's comment that traditional IoT devices were built on very imposed manner and very specific application. They tend to not have security in mind when the product is developed, and they have very little capability or capacity to support, advanced security. And now that these devices are becoming more smart and open up to become more open platform, they're hosting personalized user data and so on and so forth. Now you're seeing explosion of issues with security devices, IoT devices. This is why we're seeing a lot more demand. Vendors who are used to building these low-end IoT devices really don't have the knowledge or the experience to deal with security issues. When you connect the devices up to the network, now all of a sudden, attacks on cars or meters, all kinds of things. So we are seeing a lot of demand on that.
So, Professor, I'm going to skip over you real quick. I'll come right back to you in just a moment. Asaf, so why is this not Qualcomm's fault that all of these chips are not secure?
Well, it's always Qualcomm's fault. Come on. You can ask Intel. It's always our fault. Well, let's look first at, what is the IoT security and how it's different, right? Because we are talking about security for a long time. In my mind, there are three internet revolutions that happened or are happening. The first one is the internet revolution when we were just connected to the internet. The second revolution is the social media. And this third revolution is what's happening now, which everything is going to be connected. And each time that we move from one to another, we had more security issues. But there is something that is unique in the IoT. The IoT is the first time that there is a linkage between the cyber and the physical world. If you think before that, you just interacted in the cyberspace. Now, these devices that are connected have physical or can do physical things. It's the car. I can control the car. It's controlling the physical world. I can control other things in your house or the infrastructure. And here, the problem is much bigger, because if before we talked about, oh, my social security number will leak, which is terrible, now we're talking about actually causing physical damage. And going to your question, what is the problem? The problem is that while on one hand you have a lot of damage potential, on the other hand, the margins and the cost for these devices, there is much more pressure in there and much greater competition, and everybody are trying to cut costs. And cutting costs, as you know, the first thing that they're cutting in many cases is the security. So even when Intel provides the hardware there, or Qualcomm provides the hardware and the software and the tools, not everybody are taking them because they're saying, hey, this just adds another 10 cents to my cost of the device, and I'll just keep the security.
So I'm sure everyone in the room, speaking of physical consequences, physical damage from cyber attacks, I'm sure everyone in the room has, of course, heard of Stuxnet. How many people think that Stuxnet was actually the first attack to cause physical damage? No hands. Okay, very good. Okay, it's actually the fourth. So most people don't realize that. Okay, now let's come back to you, Professor, because you have a vendor agnostic perspective here. We have standards for security in the IoT world, IEC 62443 as an example, and there's other ones out there too as well. Are people using them?
I'm not much on the domain of standards. Usually for us researchers, the standard is a limitation. But I want to comment about your previous questions about what is the motivation of attackers in the world of IoT. First of all, the motivation of attackers is depending on where the IoT is stationed. And in the future, we are going to have IoT that are very, very close to us, the human being, actually implanted inside our body. We're going to have IoT devices that are actually wearable devices that are collecting information about us. And there are going to be IoT devices around us. The main motivation from a privacy perspective is actually to collect information. Once the IoT devices are collecting information, the motivation of the attacker is to try to access this information. Now, why it's so difficult to secure IoT devices? Because in many, many cases, from the point of view of the companies that manufacture IoT devices, these are commodity products. They actually distributed the product, and now they don't want actually to continue and to maintain the software on these products. And so nobody's going to maintain the software. So if, for example, you are going to distribute 1 million IoT devices that has an access, for example, to different information about the user, like wearable devices, from the point of view of the companies, they want to manufacture the next device. They're not interested in trying to close a vulnerability in the existing device. Now, from the point of view of an attacker, once he managed to identify a vulnerability in 1 million devices, he's going to compromise them, and he's going to use that. And nobody actually is going to close the vulnerability like in the case of regular operating system. So from that perspective, the risk in IoT devices is very, very big. Now regarding the previous comment about the physical world. Look, everybody is jumping on the example of Stuxnet because it's very, very cool. You know, it looks like science fiction. It's the first famous cyber warfare that relates also the physical stage. But in my opinion, the number of consequences where somebody is going to do an attack against an IoT to create a physical damage is going to be low, mainly because attackers prefers to do attacks that they can repeat and do them again and again, because once you are doing an attack that has a physical damage, immediately somebody will address and is going to fix the bug, and you won't be able to repeat the attack. But if you manage to do an attack that you compromise the privacy of somebody, usually nobody is going to take care for that, and you will be able to repeat and continue to do the attack again and again and again. That's the reason why in the future, in my opinion, we will not see many attacks that affect the physical world, but people are going to focus on attacks that actually compromise the privacy of user and collect information. Secondly, there's another very important aspect of attacks in the domain of IoT, which is very, very unique. Attackers identified the IoT as an amazing place for placing their botnets. Because, for example, somebody may attack your smart TV. Smart TV, it's an IoT, it's a connected device. Probably the motivation of the manufacturer to upgrade the firmware and to prevent known vulnerabilities will be very, very low. But from the point of view of the attacker, the main goal of attacking your smart TV is to use the smart TV as a connected device to attack a third party. Now, in this case, you, as the owner of the TV, you are not a victim because you are not affected. The attack can be launched in such a way that your TV will not be impacted. You will be able to see television, but your TV will be used to attack a third party. And this is a very, very complex situation because the victim is not motivated in securing his device. The manufacturer is not motivating to upgrade the device because it's an old model of a TV. He doesn't care about it. And the real victim is somebody that actually is being attacked by this compromised IoT.
I'm sure all of you heard the example from last summer about a refrigerator in Japan that was identified as being part of a botnet off of that. So compromised devices, we're talking on privacy, we're talking on the consumer side. I mean, does anyone really care that I did 400 stairs today because they hacked my Fitbit? What types of devices are people going to attack that would reveal privacy information? It seems to me a car, or cars, would be a far more lucrative, if you will, target about that. Some of you may recall, it actually came out in federal court a couple of years ago. The US government, the federal government, tried a mobster on racketeering charges, and it came out that they recorded these conversations of this illegal behavior going on, and they said, well, where did you record these? Because they didn't hold the conversations in a house, and They weren't over the phone and whatnot, and the federal government was forced to reveal the fact that they had actually hacked the GM OnStar system on the car, and they had turned on the microphone because the meetings were being held in the car. So, oops, there goes his privacy in that case. But what else for any of you? I mean, what if privacy or compromising privacy is the motivation? Really, what's the goal beyond that? Is it monetary? And what types of devices are people going after?
So I would say like medical devices, one category is going to have severe concerns on privacy.
Lorie?
Health devices definitely, and even, we see a lot of interest in energy and energy use because of the things that energy use patterns can reveal about people, whether they're home or not, which could enable a burglary, as well as how many people are in the home, even being as detailed. The analytics can be so sophisticated that they can determine what television program is being watched. I mean, it's pretty amazing.
Yeah, so let's build on that, Lorie, because that's an example that's come up very recently, or not very recently, but quite often, with regards to smart meters that the electricity companies are rolling out now and being able to gather that data. You can find online quite a bit of research about essentially fingerprinting individual devices. Oh, that was a Westinghouse refrigerator that just turned on. That was a GE microwave that just turned on at 6 a.m., and I see that pattern every morning and that sort of thing. So certainly there's some privacy issues there with regards to consumer devices. And really the whole home automation is, I think, a ripe area.
Yeah, and just to elaborate a little bit, I think there's a privacy concern there. Also, as these devices become more intelligent and part of home automation systems, there do become security concerns. I was on a panel yesterday at a different event where a Stanford professor, made the comment, I don't want my toaster to be connected. I don't want somebody to be able to burn my house down by hacking my toaster. And it's kind of an extreme example, but it is interesting.
So if you might want to find a question in the back, please. Go ahead, please.
Okay. For us, and actually, even if you look at market data, the three biggest segments for IoT are industrial or manufacturing specifically, followed by energy, and then you get into home automation. So it's in the top 3 to 4, but there is a lot of money coming in from industrial now. There's, I think in the near term, there's again, the leading revenue generators are in industrial. And don't forget, other segments that we include in IoT, are things like retail or point of sale systems and ATMs and digital signs and so on. And that, for us, is actually a significant business. But consumer, I think one of the reasons it gets so much attention is something we can all relate to, right?
Yeah, it's in that regards, it touches a lot more people, and therefore, I hate to use the word, but sexier, so to speak. On the IoT side, when it comes to industrial, the Germans revealed, without saying exactly which steel mill, that a steel mill had been attacked last year and caused significant damage to it because the industrial control system was hacked into and prevented the mill from properly cooling down. And so essentially it ruined a several $100 million piece of equipment. So these attacks do happen, but that's the rarity. Obviously, look at the recent, as we just discussed, press frenzy almost over the Jeep hacking incident, and look at how much that gets. Asaf, how about yourself? What are you seeing?
To answer the question quickly, we are mostly focused on the consumer and then smart city and things like this, less in the industrial. So if you look at the smart cities and devices that are more small or not big industrial machines, this is where we focus most. So this is our business. It doesn't mean that it represents the actual economic of IoT. But just to answer the question, so it will be interesting or to I think that when you're saying, I know that privacy it's very, very important, and people are talking about the smart meters will know what refrigerator I have. And I'm saying, well, I already have somebody posting on Facebook that they bought this refrigerator, and everybody knows, and who cares? We care, but we are not representing the younger generation. And at the end of the day, you have smartphones. I mean, we have a solution for privacy protection. We run it on Chinese app stores, and we detected that 30% of the apps on average are leaking information, like from the camera, from your microphone. So the refrigerator is your problem that they will know? They know what happens in your bedroom, right? So I think that the privacy, it is a problem, but I do not agree that saying that the physical is not a concern. So for me, as working in a company that is for profit, unlike doing academic research, I need to know what damage they can create to me and to my customers. And even if the damage is not because of the attack directly, look at what happened to Fiat Chrysler, right? Just because of the guys were saying, hey, I can remotely control your car and stop your brakes. They had like the reputation down, sales can then go down, and then they didn't have like over-the-air updates. They had to ship a USB dongle to each car owner to update their software. This is a lot of money, right? So I think that it's not just the privacy, and it doesn't mean that it will be on a big scale. And on the other hand, and when you're looking at what motivates people to do such kind of attack, it's not just the immediate financial gain. If I can go and hack into a normal appliance device, for example, and I can cause a damage, I can really hurt the reputation of my competitors. So if you look at Stuxnet that working slowly, let's say that I have a washing machine and I tweak the speed of the motor there, and after 1 year, all these washing machines are breaking down, I can put down or take down my competition. So I think there is motivation there, and I think that we shouldn't underestimate this part.
Charles, I'm sorry, please, question.
I want to ask a question from a dumb consumer point of view. Right? I think if I buy a toaster, traditional toaster, and it burns down my house, I can go after the toaster manufacturer that didn't build a safe product. If I buy, say, a Nest thermostat, and somehow someone hacks into it, burns down my house by fiddling, hypothetically, with my heating system, who's responsible? Where's the liability for that defective product? I'm just Harry. I just bought this thing and put it on the wall.
So we don't have any precedent yet in the United States for downstream liability in that case. If you talk to some of the knowledgeable lawyers in that field, both law and cybersecurity, and there's a couple of them right here locally, Steve Wu being one of them, that everyone in that section of the legal community is waiting to see a precedent happen over just that. Who is it? I mean, we're having the same debate, or nearly the same debate, over robotic cars around here. Okay? If one of these Google cars gets in an accident and kills a pedestrian, for example, who's responsible? Is it Google? Is it the instrumentation or the sensor manufacturer? Is it the software developer? Who is it? So it's an open question right now. Good question, though.
Well, at least in the payment industry, the driving factors for a lot of the security features of the product is really the legal ramifications or regulatory requirements that the manufacturer is trying to meet in order to avoid liabilities when their data is being stolen and so on and so forth. So I would say at some point it's going to legislative measures or will become a main driver for security features or security enhancement to be deployed in the IoT devices as well. Maybe not initially start with a toaster, but if toaster is really the main concern, then the manufacturer will say use it at your own risk.
Yeah, yeah.
And I think, I don't know all of the details about it, but there was one case where the FTC did fine a baby monitor manufacturer for not having strong enough security, and somebody was able to hack into it and say rude things to the baby.
Yeah. It may be the case that of all, I'll say, people or groups who end up setting the standards here, maybe Underwriters Laboratory, for example, on the consumers. I think on the industrial side, since to the point earlier that standards bodies don't exactly move at the speed of light here, it may be insurance companies and cyber insurance offerings. You're already beginning to see some of the movement in that direction through raising of premiums and whatnot off of that. So that may be a factor. So Charles, from your perspective, I mean, obviously Cadence sells to numerous chip companies off of that. Are more of the consumer-based chip companies or more of the industrial chip companies expressing, I'll say, concern, interest over IoT security? Or can you discern?
I think both, actually. So I think a lot of the consumer devices, IoT devices today are still more or less a transformed mobile device. So they bear similarity in terms of security requirements. On the other hand, we do see deep embedded, machine-to-machine industrial applications that are having dire demand on security measures. So I would say in terms of unique requirements, they're more coming from the industrial applications. Consumer devices are still more or less mobile devices, so they have similar requirements.
So there was an interesting presentation given at the RSA conference earlier this year where they actually demonstrated a crossing in IoT from consumer devices to an industrial device. And the presentation, if you go Google it, is called Security Hopscotch. And it started off by compromising, as I recall it, with someone's toaster or a wireless oven or something and whatnot. And from there, they jumped to the Nest thermostat and hacked that. From there, they jumped to his MP3 player. They had done their social engineering reconnaissance and figured out that this individual worked for a power plant and then worked backwards and found out this is where the individual lived. They basically hung out in front of his home and then, like I say, started compromising his devices. They compromised his MP3 player. And then when he took his MP3 player, or then his phone or something to that effect, I forget the exact order, and he went and plugged his phone into his computer at work to sync his music files, and bingo, infected the power plant's system, and from there got into the control room and was able to compromise the control room. So fascinating presentation, but jumping, following that trail and going from the consumer side to the industrial side. And to the point, I would imagine that we'll see more of that as we go. But I think to the point that Yuval was making earlier is that that's going to be a fairly small group of actors who are interested in doing that. Okay, that's not a probably organized crime who's doing that. That's probably a national intelligence agency who's got some sort of motivation to do that. But on the other hand, then we've got thousands of people who may go after whatever the device it is. Now, I'm not saying that POS systems are IoT, but certainly look at the scale of the attacks against those, and those have been around for many years. And obviously the chip and pin will do very little, if anything, to take care of that. In the back, please. Or let's modify that, if I may, please. What do you currently have in your home already that could be considered IoT? Lorie, let's start with you.
Probably too many things to list. I mean, we have smart thermostats, all sorts of Wi-Fi enabled, music and on. Yeah. So even somebody, I'm not too terribly worried about it. I mean, we do take, I think, reasonable precautions in terms of setting up the security on the Wi-Fi router and so on. And I think, that is something that we all should be aware of. We're talking about very, very sophisticated attacks in the example of this RSA thing, but there are a lot of really pretty simple things that people could do that would keep out the masses.
I would say perhaps the most relevant piece would be the surveillance camera that's used, although I don't have a lot of valuable goods in my house. So it's not too much of a concern, but in general, at home, that's one area that could be a genuine concern because the cameras is usually outside and so on. But one thing I'd like to point out, the reason that we got a lot of requests for industrial type of devices is there are some distinctive characteristics that are different from the mobile devices. And the consumer IoT devices are they're still relatively easier to manage, and the industrial devices, they're widely deployed in the field. They're not easily accessible. It's very difficult to remediate if something goes wrong. And they also have a very, very long lifetime, somewhere between 10 to 15 years, versus consumer devices, my daughter would probably change one of the Fitbits, and throw it away or whatever. So those are the characteristics that makes it much harder to defend for the industrial devices. And also, a lot of the devices come with very simple MCUs or CPU without the proper memory protection. So that makes the protection of the software also much harder. So that's why we're seeing a lot of demand.
Look, I am personally really concerned about putting many IoT devices in my house. I have only wearable devices and smart TVs. That's the maximum that I can allow myself. I can give you an example. I have a small farm, and I wanted to put the newest computerized irrigation system in my farm. And of course, it's connected to the internet. You can manipulate everything, monitor everything in the farm, open watering tool in the farm and everything. And I eventually decided not to buy it, because if one of my students really is pissed off about a grade, he will hack into it. And exactly like it was said here, this system is going to be there for another 10 years. Nobody is going to upgrade this firmware. Nobody is going to care to upgrade this firmware. It's connected to the internet, and you can do everything with it. Surveillance cameras, it's surveillance against me, because all of them can be hacked, and eventually people can monitor what I am doing. So why should I allow everybody to see what is happening in my house? So definitely, personally, because I know that eventually everything can be hacked, everything. And by the way, I just want to comment to your observation. I know that for you, as companies that are selling products, it's very, very cool to threaten everybody about a physical attack. But in reality, look, I'm coming from the attack domain, not exactly a typical academic person. And I'm telling you that in the attack domain, you never want to be caught. And usually when you are doing an attack, and it's only once you can do it, you can't repeat it. On the other hand, for intelligence, for collecting information, you can use the same attack infrastructure again and again and again. For that reason, attackers try as much as possible to focus on the intelligence domain. And when it relates to IoT, IoT is collecting a lot of information from the environment. So either you are going to try to attack the IoT device itself, because the IoT device itself can access to information, like in a surveillance camera, or a wearable device. Or for example, in a manufacturing environment, the first thing that an attacker will try to do is to attack the IoT device to understand exactly what is the process that the company is using, and not to disable the process. I want to understand exactly how, for example, Mercedes is assembling their cars. First of all, as an attacker, I want to understand what they're doing there, to collect information from the IoT devices. The last thing that I want to do is to attack the production line itself. This is something that I can do only once, and somebody is going to try to investigate who did it, and eventually they might catch me. Now, the problem with IoT is, first of all, it's multiple devices having access to a lot of information, and in addition, what is being done today, this information is even sent to the cloud and stored. So in most of the cases, attackers will try even not to attack the IoT device themselves, but to attack the information that is collected, it is being stored in the cloud. And relating to the previous comments about medical devices, that's the biggest risk. Today, people are collecting a lot of information. Who knows what analytical algorithms we are going to have in the future that we're able to derive exactly what is the life expectancy of somebody. And this information has a huge value for insurance companies, for example. So that's the consequences of the fact that we have many, many devices connected. Nobody wants to upgrade them. They are collecting information, storing them in the cloud. That's the real risk in the IoT domain.
Charles?
So I think that statement basically reflects that, to the general public, the understanding of the severity due to data loss, privacy breach, is not as high as the understanding of the severity caused by physical injuries. To some degree, if you say if you don't take the security measure, your house is going to be set on fire or your car is going to flip, that's bad, right? But if you say you're going to lose somebody is going to collect which shops you've been to ordinary people, probably they don't care. So yeah, you collect how I behave. So what? So that's kind of the general feeling that why physical damage has been probably put on higher spotlight or bigger spotlight.
So just to answer your question, the security solutions that I have from privacy is just saying, I'm so boring, who will interested in me, and I don't have any money, I spend everything, so they will not take anything. But seriously, first I agree with everybody here. The thing that worries me the most is these devices that are dusting in some corner and they are connected, that I forgot about them. So if I look at everybody, when you're asking what IoT device do you have at your home, everybody thinks about smart TVs and things like this. And I was thinking, well, I have a printer that is Wi-Fi connected that I never updated. And actually, I can't update it if I want. So even the trivial thing, they're sitting there and they have no security. And more than this, what terrifies me is that I'm meeting with the big brands on consumer electronics, right? And you go to them, and while, in the mobile and other spaces, they use security practices that are known. You're asking them, well, now you're building a microwave or a vacuum cleaner or whatever it is that is connected. Do you use SSL? No. So even the simple thing, the basic thing that we all know, it's new to them. And it's new to them because of cost or because this is the organization that they used to do refrigerator. They were never connected. Now when they connect it, they just buy the chip that connects it and they put it there. They don't have in their mindset, even if the bigger organization in the company has a security team, they don't have in the mindset to have security there. And this is the thing that are frightening me. And then just to continue the discussion here, the problem is not necessarily have to be somebody that is causing the damage, from my perspective. It can be also one of your students that will want to demonstrate, because nobody, if they want to make a name for themselves, not talking about it, not be able to show it, there is no fame for them, right? So they go after the physical things, and then they show how I hacked that and I can cause that damage. And this creates fear on consumers, especially in consumers. And this fear is translating to people not buying the devices, which translates to a lot of money.
Those are not hackers. Those are security researchers.
This is my dear friends here.
No, it translates a lot of money to companies.
Well, I think what is clear is that there are different motivations that drive this. You have some people who are interested in collecting information, if you will, intelligence gathering. It may just happen to be on millions of consumers for that, and they're going to do something with it, somehow monetize that data. You have other people who are interested in disruptive attacks. I just want to fool the traffic control system or whatever and snarl traffic for this morning's rush hour, this afternoon's rush hour. You have other attackers who are motivated by destruction. And there's been an increasing number of attacks that have been actually destructive. So when 30,000 systems at Saudi Aramco get bricked, okay, that's pretty destructive. It's also disruptive, but it's pretty destructive. And there have been other ones as well. So again, I think the point is that there's multiple motivations. Some of this may be, frankly, for the sheer lulz of it, and I just want to make a point, particularly in your part of the world. There are different groups. You don't exactly live in a good neighborhood, so you have different people who have different motivations to try and embarrass different parties. So, Other questions from the audience, please? Other than our journalists in the back, you're all too quiet. Come on, come on, come on. Okay. So many of these attacks that do occur are taking advantage of weak or non-existent encryption of the communication links. And the traditional communication links, whether it's TLS, et cetera, tend to be way too heavy, if you will, computationally for the small devices that they're put in. But we have a whole series of approved, lightweight, secure communications protocols. Now, I'm not talking about Zigbee here or Wi-Fi, all of which are susceptible and have been hacked, but we have secure protocols over those channels. Why are those not being used?
So I'm not,
Because no one knows about them.
so at least I don't know which specific one that you're referring to, but in general, I think the devices are vulnerable because of several reasons. One is that most of the IoT devices today lack of fundamentally a way to be authenticated. When they attach to a particular network, it's very hard to prevent some rogue devices from entering into the network. Another thing, as I mentioned earlier, is that the CPU or the MCU that's being used in those devices lack of even basic memory protection. And so there's no separation of software layers. Pretty much it's a homogeneous code space. Now, if you do only one function, that might be okay. But if you now try to be smart and put more apps from different vendors into that system, then it becomes very problematic. Lack of protection of storage is also another area that's tend to be very problematic.
Data at rest
Yes,
is
go ahead,
typically
please.
not encrypted. So, question, please. The difference between our comment on network security versus endpoint security. Okay, so around the cloud security specifically versus the devices
Right.
themselves? Okay.
So I'll give my spin on it, right? So if you look at the network security, there are really two aspects. One is to be able to establish the secure channel through authentication. The other one is to be able to protect the data that's in transit. In general, to protect the data in transit, has the protection mechanism or the technology or standards have well been established. Some were weaker, but they are getting better. The problem has been that for the IoT devices, how do you authenticate and allow the allow the IoT devices to enter into a particular network? Especially for devices at large, if you're talking about car-to-car communication, how does that work, right? Which car I'm talking to. So that becomes more of a problem to be solved, I think.
Yeah, I'll comment on that while you're passing it off. In terms of the consumer devices here, when you've got millions and millions of these things that are out there, do you think, and I'll pick on them, and I'm just an example, but I'll pick on Fitbit. Do you think Fitbit is going to put individual authentication on those devices? No. The problem we run into is while they pay some lip service to that, it's around shared keys, okay, off of that. So if all I have to do is compromise one, and now I have the keys to, in this case, really the key to millions of devices. So authentication is problematic to say the least. And if the encryption mechanism for encryption of data in transit somehow is relying on either the same key to do the encryption, well, that's blown now too. So it's very, very problematic. Lorie, you were going to say something?
I was just going to comment, especially industrial IoT applications, being able to verify the integrity of the device really calls for device level security, not just network security. Because you want to know that the data you think is coming from the device is really coming from that device, and then it hasn't been compromised somehow, so that the data's been manipulated. So it's, you can't use one to substitute for the other.
Yes, I just want to comment on that. That's really, really important. We just talked about the possibility of compromising an IoT device, but what about the situation in which somebody, take the example of Fitbit, somebody will be able to create a fake Fitbit that represents you and start to send information to the Fitbit server. Somebody is going to compromise Fitbit server, but actually the data there is not your data. It's data that somebody actually planted there.
That wasn't me who registered on Ashley Madison, by the way. That was
Exactly. That's a big challenge.
Please.
You talked a lot about consumer devices and the fact that they can be compromised because of cost and technology problems. When you get to the opposite end of the spectrum, when you're talking about air traffic control or nuclear power plants or airplanes, does the technology exist to make systems that are simply unhackable? Do you have confidence about that?
No. I know what is happening, by the way, today in the aviation domain, in the civilian aviation domain, and you can't imagine, I don't even want to comment about how it is working today. And just to give you an insight, pilots are using iPads in the cockpit in order to do certain decisions. So definitely everything can be hacked. It's just a question of what is the effort vis-a-vis the benefit. In the case of cybercrime, this is the biggest challenge for us, because in the cybercrime, what we try to do, we try to raise the barrier of the security in such a way that the cost of launching the attack will be higher than the benefit. In the case of state-sponsored attacks, the cost is not an issue, and eventually states can do whatever they want, especially in the aviation domain, by the way.
Any final comments? With that, how many of you are flying home tonight for reassurance? It's a long walk. Any final comments from any of the panelists? No? Harry, none? Okay, I think we're done. Thank you for being here. Thank you, panelists.